29. For each of the following molecules, indicate the hybridization requested and whether or not the electrons will be delocalized. Okay, and then we have ozone, which is O3, and we have to find the central oxygen's hybridization. You got it. And whenever we want to find out a hybridization, the easiest way to do this is to find the Lewis structure first. It is one extra step, but I promise you, if you have a visual, finding the hybridization would be so much more easier. So let's get down to it. Now we do have a playlist going over Lewis structures, and I have the rules written on the screen. So if you need a more in-depth explanation, you could always go back to those videos and watch them. But this will kind of be like a quickened version. Now in this case, I just have 3 oxygens. So they have to be all, bound together in a single line. So I have 1 oxygen, I got another one, and another one. Another one. Who's that? Another one. Anyway. Yeah, let me know in the comments. So, back to chem. Let's put our valence electrons around each oxygen, right? Oxygen's in group 6A or 16, so that's 6 valence electrons. So maybe I'll do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. No adding or losing electrons, so dot to dot, and let's see what we get. So dot to dot, that's a single bond. Dot to dot, that's a single bond. And let's see what's going on here. So I always like to do the external elements first, because if you could get the octet rule on the external elements, your internal element is going to be fine. So this oxygen has 2, 4, 6, 7. Meh. It's got 7 electrons. It wants 8. It wants the octet. But I do see that I have a lone electron here and a lone electron here. So what I can do is this electron will zoom up. Zoop. This electron will come over here. Zoop. And dot to dot, they will form another bond, right? Giving you the double bond. Whoopee. So now this oxygen is good. 2, 4, 6, 8 electrons. Okay. So now this oxygen, right? 2, 4, 6, 7. Same issue. But now I see that I have 2 dots. So I say, well, maybe I can do the same thing that I did, right? If I make a double bond, this oxygen's all good. But is this oxygen good? Not really, because it's got 2, 4, 6, 8, 10 electrons. Oxygen is not one of those elements that can have the expanded octet, meaning more than 8 electrons. So I can't do that. But what I can do is instead, this oxygen says, well, wait a minute, I'm going to have too many electrons anyway, and you need the 1 electron, so I'm going to just give you it. And this electron goes to that oxygen. And now, this oxygen has 2, 4, 6, 8 electrons. That's the octet. And this oxygen has 2, 4, 6, 8 electrons. So we're all good. Now, what we're going to do is, I guess we'll do the hybridization first. So they wanted the central oxygen. So that's this. And if we want to find the hybridization, there's 5 different types. It just talks about the certain orbitals that overlap to form the bonds, right? And hybridizations go from sp to d, right? So we have sp, sp2, sp3. And just know that between the hybridizations, right, you just have to worry about how many letters there are. So like for sp2, I have an s and 2 p's. That's a total of 3 letters. If I just tackle on 1 more p, that's sp3, and that's a total of 4 letters. And those number of letters corresponds to the number of things. One thing is either 1 single bond, or 1 double bond, or 1 triple bond, or a lone pair. Don't get confused that, a double bond is 2 things. It's one whole thing. So I look at the oxygen and I say, what's going on around oxygen? Well, it's got one single bond, that's one thing. It's got a lone pair, that's two things. And then it's got a double bond. That's three things. Nothing else around that oxygen. So three things, three letters, sp2. So that's the hybridization of the central oxygen. And now the last thing we have to do is just determine, can the electrons be delocalized? Now, delocalization, or delocalized electrons, means that some of the electrons are not bound specifically to a certain bond. They're free floating. Basically, you can find out if electrons are delocalized if you have a drawing that shows a double bond and you have two of the same elements on both sides. So for example, in this example, if I just take away this coloring, we put the double bond on this side. So I say to myself, well, can I just take this double bond and move it over here and put the single bond over here, right? Could I have done that? Absolutely, right? And then this one lone pair goes over here. So basically the oxygen swap. Do you see that? I'm going to put them back, right? Boop, 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 boop. It was basically a reverse, right? So could we have done that? Yes, we could have. So when you can basically have the option to choose which side, do you have the double bond here or do you have the double bond here? Because the two elements are exactly the same, that is when you know that you have delocalized electrons. So will the oxygens be delocalized? Yes, you have delocalized electrons in this case. If we weren't able to do that, then we would say that they were localized, not delocalized. And that's it. That's the other answer. All right, let's box this off and call it a video, right? Okay, color it in. I'm done with that. Anyway, I hope this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel if you haven't already. Thank you so much. It just gets the word out there that this channel exists. And I hope you're doing a great job out there studying hard. And I hope you have a great day. Talk to you later. Bye-bye.